Hi, Mr. Wartsky here again, and today we're going to start off on a brand new module. This is organic molecule. So let's get started. Now remember, if you ever need to listen to the recording again, you can. If you need to pause it, you can. You can also refer to your textbook. So we're going to start off with the introduction by defining certain things. For example, isomers is an interesting term in which the molecules have the same molecular formula but a different three-dimensional shape. Now there are three different types of isomers that we'll be dealing with. The first are structural isomers. The example is a great one, glucose and fructose. They both have the molecular formula C6H12O6. That's again C6H12O6, but you can notice the difference between glucose and fructose. Glucose is a hexagonal in shape, where fructose looks like a pentagon. So although they have the same molecular formula, they have a different three-dimensional shape. And as we will find out later, shape is everything. The second type of isomer, the geometrical isomer, we're not going to really be dealing with that a lot, but that's different arrangements around a double bond. So if we take a look at the example provided here, we have the double bond here and the double bond here. You notice that the sulfur is on top and the methyl group is on the bottom, whereas it is switched around here. And that actually makes a big difference because it provides a different three-dimensional shape, which we'll find out later. Shape is everything. The last type of isomer that we are going to be talking about are stereoisomers or enantiomers. They are mirror images of each other. So they have a central carbon, which is called a chiral carbon. And we'll learn about a chiral carbon more when we talk about amino acids. But there are two shapes. They're right-handed and left-handed. The example that I give, ironically, doesn't have a central carbon, but it's called thalidomide. And thalidomide is a drug that was given to young women back in the day, 70s and 80s, to reduce morning sickness. And if they got the wrong stereoisomer, then their child ended up with severe birth defects. So they do have implications because shape is everything. You're right. So those are isomers. And if you again need to review that, please by all means go back and you can listen to me again or just take a look at the slides. The second term will be a carbon backbone. And a carbon backbone is composed of a lot of carbons that are bonded to other carbons. And I provided you with an example of a carbon backbone on the bottom. And carbon backbones can form hydrocarbons, which are composed only of carbon and hydrogen. And you have an example there of octane, 8 different carbons. Functional groups are groups of sponge elements, and we know all about sponge elements as sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. And they are involved in chemical reactions. That's what functional groups do, because they behave in characteristic ways. Now, these functional groups are attached to the carbon backbone, which we just talked about. So basically, you take a hydrogen off, and you plop one of these functional groups down. Now, you might be asking yourself, what are some examples of functional groups? And here they are. The formulas are on the left-hand side. We have the group name and significance on the right-hand side. These are the main ones that we will be talking about over and over again, like the hydroxyl or alcohol groups. The amino groups, when we talk about amino acids, again, the carboxylic acid, when we talk about amino acid, the acid part of the amino acid group. Self-hydral, we talk about protein shapes. That'll become really important. Phosphates will come to play in amino acids as well as DNA and methyl groups. So you're going to come across these things. I want you to get them down on the table. So you're going to have to hit pause and get that down. If you could, please. That would be great. Form a table. I'm sure there'll be a quiz question or two about that we talk about when you have your quiz tomorrow. Monomers and polymers. So you have to understand monomer means one, polymer means many. Monomer is the basic unit. And what we'll do is we'll add monomers together to form a dimer, di is 2, or a trimer, tri is 3, or a polymer, which is many. So how do we add the monomers together? Through reactions. Now this reaction is just one reaction that has 3 different names. You can either call it a condensation, a dehydration, or synthesis reaction. We add the monomers together and you release water. We break polymers down into monomers or dimers or trimers through what is known as a hydrolytic cleavage or hydrolysis. Hydrolysis is the killing with water. We add water to break apart the polymers. So condensation, dehydration, and synthesis, we put them together and make larger molecules. And hydrolytic cleavage or hydrolysis is when we add water and we break things down. Now I have on the next slide an example of a synthesis or condensation or dehydration reaction. Right, so we're going from the top. When we add glucose and fructose together, you'll notice that they circle the hydroxyl group, one of your functional groups, and a hydrogen, OH and H yields H2O. The H2O comes out and you form a bond here, and now you have two monomers added together, which is a dimer. That is the synthesis, condensation, or dehydration portion. When we're going from the top down. Now this is sucrose. That's common ordinary table sugar. So now how do we break it apart? Through the hydrolysis reaction, we're going to add water. So when we go up, we're adding water. Water is coming in, and we are going to add the OH group here and the hydrogen there, and we will now have two monomers forming from a dimer. So that's the hydrolysis reaction going up. Synthesis going down, hydrolysis going up. Yes, I would like you to draw that. So again, hit pause, and now you will have an example of both synthesis as well as hydrolysis. So there are four types of organic molecules, and of those, there are carbohydrates. I call them CHOs because they have carbon, hydrogen, and oxygen. That's a great abbreviation because carbohydrates are a longer word to write. With lipids, nucleic acids, and proteins. And we're going to focus on those four organic molecules, starting with the second screencast, which would be organic molecules 2. So we're done for this for today. If you need to look at it again, by all means do so. Thank you.